Welcome, Calculus BC. This is lesson 5-6, solving differential equations and exponential growth and decay. Let's begin. So what is a differential equation? Well, these are equations where you have a y prime or a dy dx in there. So here's some examples. I got a y prime right here, dy dx here, or even a y double prime. So those are all differential equations. Well, what makes a differential equation interesting? What can I do with that? First thing I might want to do is find something called a general solution or general equation sometimes. And this means we're getting rid of the differential part. So we're getting rid of the y prime or the dy's or the dx's. These are all like the differentials. And when you get rid of that, you're eventually going to have a plus c. So think you're going to be doing integration at some point. So after you find the general solution, sometimes you might also need to find a particular solution. So a particular solution means you just figure out what the plus c is. And you've done this before with integration. So we usually are given some kind of initial condition, and you plug that in for your x's and y's and solve for your c. So your procedures for solving differentials, this is kind of a general rule here. The first thing that's usually important is you want to rewrite your y primes as dy over dx. And this is going to be important later. So rewrite those if you need to. You also want the dy dx to be on the top. So you might need to multiply both sides by dx, and this would end up canceling out, and it'd be basically you have to move the dx part to the top. And at some point you're going to have to separate the variables. So what I mean is you have your equal sign, so you have your y's on one side, which includes your dy, and your x's on one side, including your dx. So you want to get those isolated on each side. And then at that point when it's isolated, then you can integrate both sides of the equation. So the goal is kind of that dy and dx is the right-hand side of your integration. So integrate something like this, and you know how to do that. And you're going to have a plus c somewhere when you integrate. You just have to add that plus c to one side. You don't need to have a plus c on the left and a plus c on the right. So you just put it on one of the sides. Doesn't matter. And sometimes we ask you to solve for y, so we turn it into a y equals equation. Not always, and in all cases you can't. But if you need to, make sure you rearrange it. And then if you need to solve for a particular solution, use an initial condition to solve for c. All right? And here's your general guidelines. Let's just do some practice. So this might be a typical one. Find a general solution of x plus 2y times y prime equals 0. So my first step is to put this as dy's and dx's. So x plus 2 times y times dy dx equals 0. Now I don't want to just multiply. Well, I could just multiply by dx on both sides first. Sure, let's do that. So multiply by dx first on every term. 0 times dx is still going to be 0. These dx's cancel, so this would be x dx plus 2y dy equals 0. Now I want to get the x's to the other side, so I'm actually going to subtract x dx on both sides. So I get 2y dy equals negative x dx. And at this point, since everything's separated, I can integrate. And after you integrate 2y, integral of that's going to be 2y squared over 2, which actually just reduces to y squared. And on the other side, negative x becomes negative x squared over 2. And we need to have a plus c somewhere. Let's put it over here. Could have put it here. Whatever. So there is a general solution for this differential equation. Now, let's do something else again. Find equation of a function which contains the point 0, negative 3, and whose slope is this for each point on the curve. Okay, so a few vocabulary words here. This is what we did before. But when I ask for an equation of a function, that means I want to put something in y equals form or f of x equals form. So this means I'm going to rearrange. This point right here is initial condition. When x equals 0, y equals negative 3. And when I say a slope is this, that means dy over dx, which is our slope, is going to be x e to the x squared over y. All right, so basically I'm going to take this equation and find the general solution and put it in y equals form, then use this condition to find the plus c. So let's see what that works like. First, we got to find the general solution of this equation. So what I'm actually going to do is I'm going to multiply by dx on both sides, just like this. And so these cancel out, so I get my dy equals x e x squared over y dx. And I want to get my y's on both sides, so I'm going to multiply by y. On both sides, these end up canceling. So what I'll have is y dy equals x e to the x squared dx. Sweet. So let's integrate. Integral of y is going to be y squared over 2. Right here, you have a u sub going on, so I'm going to do some work on the side. Your u would be x squared, and du is going to be 2x dx. I create the 2, so I must multiply by 1/2. So you get 1/2 integral of e to the u du, which is going to be 1/2 times e to the u, which is 1/2 e to the x squared. So y squared over 2 equals 1/2 e to the x squared plus c. Okay, so we got to make this a function, which means y equals forms. So I'm going to take this equation, and we're going to do the work this way. We're going to multiply both sides times 2. So I get my y squared, a lot of work here, equals e to the, now we're going to multiply all this by 2, e to the x squared. So if you multiply everything by 2, so these cancel, those cancel, so I say plus 2c. Okay, and then I want to isolate the y. The neat thing, if it's 2c, it's 2 times c, and c are just constants, so you don't really need to put that, because it's just a constant at this point. So we want to square root both sides. So I'm going to say my y equals e square root of e to the x squared plus c. Yes, and you keep it underneath here. Okay, so here's my general. Now I got to find a particular. So when x is 0, y is -3. So, well, one note, this is plus or minus here. Remember, or plus or minus. So -3 equals negative square root of e to the 0 power plus c, which is negative square root of 1 plus c. It's -3. That means 3 equals square root of 1 plus c. Square both sides. 9 equals 1 plus c. So your c equals 8. So my particular solution after all of that work is going to be y equals negative square root of e to the x squared plus 8. Whoa, a lot of work. Okay, another part of this, exponential growth and decay. So this is like one of those applications of what we just did with differentials. So sometimes in the real world, we use mathematical models to model a rate of change of a variable, and it's proportional to the variable itself. So the equation kind of looks like this, and that's really gross format. But dy over dt, so like the variable y is equal to k times y. That means as y is changing over time, the slope of y is relative to the height of y, kind of. So what happens if I find a differential equation for this, or I find the general solution? So I'm going to write the dy dt equals k times y. K is just some constant. So we're going to move the t to the other side. So in this case, instead of multiplying by dx, we multiply by dt. So I get, and then I'm also going to divide by y on both sides, because doing this in less steps. So I'm going to get 1 over y dy equals k dt. And you're going to integrate those. So if you integrate this, integral of 1 over y is ln of the absolute value of y. And k is a constant, so it'll be kt. Now, let's say I wanted to find an equation, put this in y equals form. Well, how do I get this y by itself if it's a ln of y? To get rid of a ln, we e both sides. So e to the ln of y is just going to be y. Oh, remember there's a plus c. So, oh, my bad. So I'm going to put the plus c over here. So you're eing this entire thing in the exponent. So I say y equals e to the kt plus c. A neat thing with this, when I say plus c and this is a different constant, this is the same thing as e to the kt times e to the c. All right, I can break up laws of exponents. And really, e to the c is just a constant c. So I can rewrite that as just c times e to the kt. And this is one of those important formulas that we're talking about right here. This is the basic law of exponential growth and decay. You might have seen this in Algebra 2. So y equals c e to the kt, and where c is the initial value, and k is your proportionality, and so on. So we could do an example of this, but we're just going to do these in class. All right, I'm done.